Hello and welcome to SudoKanard. We are here to solve this killer Sudoku that I created a few days ago and which is rather difficult, I must say. And I themed it around pentominoes. You can see that all cages have exactly 5 cells, and this 5 is the icing on the cake, but it was absolutely not intended in the first place. It just came, it just happened. So the special rule of Kira Sudoku, as most people will be familiar with, is that all digits must be different in such a cage, and the sum of all those digits is the number in the corner of the cage. So that's all, and I will put a link in the description. This is a puzzle that I shared on Puzzle Expo on Logic Masters India. If you don't go to Logic Masters India, then you can still try the PenPa interface that I gave in the description. So first thing, we have some cages here which are notably, well, if you're familiar with Kira Sudoku, you know that 34 must be 4, 6, 8, 9. It's not very convenient to pencil mark all those digits. I would just pencil mark the, the outliers 1, 2, 3, 5. And if you're familiar with Kira Sudoku, you know that 35 is 5, 6, 8, 5, 6, 7, 8, 9, so that this can be placed right from the get-go. That's a 5. And those are 6, 7, 8, 9. So something else that you must know is that the sum of all digits from 1 to 9 is 45. And here we can see that those two cages use almost all 9 digits. I will use some coloring for that. You can see that those 8 digits are common to those, well, this box, this 3 by 3 box, and the union, oh, I won't try to say the word. The addition of all digits in both cages. So if you add those two digits, you come to 39, but if instead you add this digit, you come to 45, which means that this digit here is 6 more than this digit plus this digit. The minimum value for those two digits is 1 plus 2, 3, and 6 more has a minimum value of 9, so that this digit has to be a 9, and those two digits have to be minimum. So they have to be 1 and 2. So this is really the intended logic for the start, to see that we are in a case of minimum and maximum value. And something similar is happening here, namely we have 61 for all those digits, and we have 45 for all those digits. 61 minus 45 is 16, so that those two digits must be 16 more than this one. So the minimum value for those two digits is 17, which can only be achieved with 8 and 9. So the minimum value is also the maximum value, and this has to be a 1. Now we are facing something similar with all of this. We have a total of 40 compared with 45, which means that this is 5 more than this plus that. So this is 8 at minimum, and the maximum value is also 8 because of this 9. So this must be 8, and this is finally a 1-2 pair, and this has to be a 3. All right, so next we have this, which sums, those digits sum to 60 compared to 45. So this plus that must be exactly 15 more than that. And this has a minimum of 2. So those two digits have a minimum of 17 and maximum of 17. Therefore, they must sum to 17. And this has to be a 2. So that is the intended initial break-in, and the puzzle is not quite finished after that. So what else can we see? Something else that we can see is that in this column, none of those three digits can be 1 or 2. This because of that, because of the box logic, this because of the cage logic, and this because of the cage logic. So in this column, 1 and 2 must be there. And the same is happening in this column with 8 and 9. They can't be here by cage logic, they can't be here by cage logic, they can't be here by box logic. So in this column, 8 and 9 must be there. All right. Here, 31 cage. We already have 3 and 8, so the remaining 3 digits must sum to 20 without using 8 and 3. So what could they be? They could be 9, 4, 7, or they could be 5, 6, and 9. But there is a 9 in there, and you can see that 5, 6, 8, 5, 6, 7 are all forbidden here. So this must be from 4 and 9. 7 and 6 are forbidden here. So this must be from 4, 5, and 9. So what are the options for this? If this is 4 and 9, then this must be 7. 4 and 5 here is impossible. So 9 must be there. If this is 5 and 9, then this must be 6. Oops. This must be 6. So we have a 6, 7, 8 triple here. And the 8 is in one of those. So this can't be 8. So this was the next logic. Now let's look at something. Here we have 22. So that the sum here must be 23. Here we have 20, so that the sum here must be 25. Let's use some coloring. So here we have 25, here we have 23, which makes a total of 48. But we know that those 4 cells are exactly 1, 2, 8, 9, summing to 20. As a result, the remaining 4 cells must sum to 28. And this is important. Now, let's have a look at the possible values. Sorry about that. Let's look at the maximum values. In this column, the maximum values here are 6 and 7, which sum to 13. So the maximum here is 13. So the minimum here to have a total of, let's remember, 28. So here, maximum 13. So here, minimum 15. Minimum 15, so that this digit can only be a 9. And this has to be a 4. And this has to be a 7. So 7 is not here, 7 is there. So that those two digits sum to 16 after all, and those two digits now must sum to 12 to achieve a total of 28. 12 without using those two digits, they must be 5 and 7, so that this is 5, this is 7. So this was the next intended logic for this puzzle. And I will remove the coloring, which has served its purpose now. Let's look at this. This 18 cage, we already have 9, so those 3 digits must sum to 9 without using the 2. The only option is 1, 3, and 5. So 3 must be here, 5 must be here, and this must be 1. Here we have 2 and 9. 2 can only be here because of the 8, 9 pair there. This is 9, so that this is 8, this is 9. Inside this box, this is now 9, and this is 8. This 24 clue, we already have 17, so that this has to be 7. This 8 turns this into a 6, and that is an 8. This one here disambiguates the 1, 2 pair there, and this 2 turns this into a 1, and this into a 2. Where do we look next? This 22 cage already has 3, or is this the place to look? I'm wondering. Let's see, we need 3 and 4 on this row. But because of this 3, this is 4, this is 3. Here we need 6 and 8 on this row because of this 8, this is 6, this is 8. So here we have 6, 7, 9. That's not 9. This column still needs 4, 6, and 7. Here we need 1, 2, and 4, so that this is 4, this is 1 and 2. And those two digits now must be 3 and 6. All right, so where do we look next? The puzzle is not finished, really not. So where do we look? Those 3 digits must sum to 17. No, we already have 17. They must sum to 16. So they could be 3. If this is 6, then those must be... If this is 3, then those must be 6 and 7. And namely 6 here and 7 there. If this is 6, we have 23. We need another 10 without using 6, 8, or 9, so they must be 3 and 7. So there is a 7 here, and this is a 3, 6 pair. Now for this 31, we need another 14 without using the 7, 8, or 9. So I think I say 14. So 6, 5, 3 is an option. Is this the only option? 6, 5, 3, yes, that's the only possibility. So 5 goes there, and we have another 3, 6 pair. The remaining of the column is 1, 2, 4. So this is from 1, 4. This is from 2, 4. And here we can see an XY wing. Well, people call that a Y wing, I think. Namely, knowing that this is 2 or 4. If this is 2, then this is 1. If this is 4, then this is 1. So one of those digits has to be a 1, and therefore this can never be a 1. That has to be a 2, so that this is 1. All right. Where do we look next? 5, 5. So there is a 5 up there. And that is interesting, because there are only 2 ways of having 5 digits summing to 17. One of them is 1, 2, 3, 4, 7. 1, 2, 3, 4, 7, which is not the case here because of this 5. So knowing this has to be the other option, 1, 2, 3, 5, 6. So this is 1, 2, 3, 5, 6. And those don't include the 6. They must be 4, 7, 8. So 2, 3, 5, 6. Those are from the 2, 3, 6. This is not 2. And we get a 3, 6 pair here. And something I could have noted earlier is that this has to be a 1. So 3, 6 pair here. This digit 4 or 8 must go there. And this 7 now must go here inside this box. This is the missing digit from 2, 4, 8. Oh, sorry about this. This must be from 2, 4, 8, 9, but 9 is not here. Actually, 9 is there, and this is 8. All right. So 8 is in here. This is correct. Those must be from 1, 4, 5, 9. I could pencil mark those. That doesn't seem to be that interesting. This column still needs 5 and 3. There's a 5 here, so this is 3, this is 5. This column still needs 4 and 6. This is not resolved yet. Those are from 4, 6, and 8. I will pencil mark them. Those two allow me to place a 2 inside this cell, and those are from 3, 4, 6. There was probably no urgency for those digits to be played. So what else can we look? This 22 cage. Oh, 18 doesn't use the 9. There are 3 ways of achieving 18 with 5 cells. 9 is never a part of them. We can see that 9 is not here. So inside this region, 9 can only be here. So this is not 9, this is 9. Now those 3 digits sum to 12. So those 2 digits must sum to 10. This must be from 4, 6, and 3, which create a 3, 4, 6 triple. And those 2 digits now must be 1 and 5. 1, 5. What can we see? An interesting point is that 5 is nowhere here, so 5 must be there. So this is not 5, this is 5. And this is from 2 and 6. And on this row, 8 can only be here. That's not 8. 2, 3, 6. So that those are 1, 5, and 7. 7 goes there. This is 5, this is 1. And to complete to 18, this has to be a 3. So this is not 3, this is 3. And now the rest should just collapse. 6, 3, 4, 6, 7, 6, 4, 8, 7. This is a 5. This can only be a 1 because of this. That's a 9. That's a 4. This one turns this into a 2. That's a 1. That's a 3. That's a 6. That's a 4. This is 8. This is 2. This 4 now resolves all of this. And 6, 3, and 2. So this was quite a journey. There was definitely some work to do to solve this killer Sudoku of mine, but I must say I'm very satisfied with the way the puzzle turned out in the end. And you see that there was really no bifurcation needed. You just had to find the right combination of cells. Thanks for watching this video, and see you soon on SudoKanard.